Okay, so let's do an example. Change the order of integration and then evaluate. So we're given integral 0 to 4, integral square root of y over 2 to 1 of y to the minus 1/2 e to the x squared power divided by 2 dx dy. Okay, so if you tried to integrate this, you'd have to integrate with respect to x first and let you check. You'd run into some difficulties. I guess you could try and let u equal x squared, say here, but then your du dx would be 2x. There's no 2x over here, so u substitution would not work. So basically you could not integrate it with respect to x first. To be difficult. So we're going to change the order of integration here. So we're going to change the dx and dy around here. But in order to do that, we're going to have to first look at the region here. Okay, so let's make some observations. So our first observation is that y is between 0 and 4 because y is the outer one and the outer integral goes from 0 to 4. So y is between 0 and 4. And the x then, it will be from this guy to that. So let me write it here. So now we're x greater than or equal to square root of y over 2 and less than or equal to 1. Okay, so now let's see, let's set x equal to the square root of y over 2 and solve. So setting x equal to the square root of y over 2, let's multiply both sides by 2. So I get this, and then let's square both sides. So we get this, squaring both sides, we get y equals then 4x squared. Okay, so now let's see what happens when y is 4. So let's look at that. So now when y is 4, then the square root of y over 2 would be square root of 4 over 2, which would be 1. This would imply then, well, since x is between square root of y over 2 and 1, when y is 4, x will have to be 1 there. Okay, let me write that. So this implies x is 1. So again, because x is between square root of y over 2 and 1, but when y is 4, this becomes 1. So you'd have, that forces x to be 1 then, so x is 1 in that case. Okay. Next, let's look at when y is 0. So when y is 0, then the square root of y over 2 would also be 0. Okay, so let's now try and graph this region. So let me do that. Okay, so to graph a region, we know when y is 4, x is 1, so it'd be a point here. And then when y is 0, then x can be anywhere between 0 and 1. So it looks like, well, I guess looking at the y equals 4x squared, it put you right here. So if I graphed y equals 4x squared, it would be a parabola going up like this. And now I claim our region will be this side of it. So let me explain this. Okay, so if you look at what we have up here, y goes from 0 to 4, that's fine here, and x goes from square root of y over 2 to 1. Well, if you took this integral up here, you're doing dx dy, so if you took strips this way, it would go from the parabola, solving it for x, which would be square root of y over 2, to 1. That's how I'm getting there. And then y goes from 0 to 4 up here. Okay, so we're going to switch to order of integration. So to do that, we're going to do vertical strips here. So we draw a vertical strip in. So here's my vertical strip. So doing vertical strips, the y is going to go from 0 to up in the parabola, which is given by 4x squared, and the x will go from 0 to 1. So let me erase a few things and let's summarize what we have. So summarizing, so we're trying to integrate over this guy. We drew the region here. So integrating this over this one, we'll be doing strips this way. Okay, so when it switches, so we're doing vertical strips. So let me do that. Drawing the vertical strip. Okay, so I've drawn in this vertical strip here. So y is going to go from 0 to the parabola up here, and the parabola is given by y equals 4x squared. So it's going to go from 0 to 4x squared here, and then x is going to go from 0 to 1. So let me put those in. So we get this then, so 0 to 4x squared, 0 to 1 here. So we're integrating now with respect to y first. So therefore the ex squared is treated like a constant, so we're just integrating e to the minus 1/2. So we're going to add 1 to that, divide by the power. So let's do that. So integrating y to the minus 1/2, so adding 1 to that to be 1/2. Then you'd be dividing by 1/2, which would be the same as multiplying by 2, but then the 2's would cancel here. So you just get y to the 1/2 e to the x squared, evaluated at 0 and 4x squared. So I'm going to put 4x squared in place of y here. So let's do that. So putting 4x squared in place of y, it's the square root of that then. So the square root of 4x squared will be 2x. So let's have a 2x here then. E to the x squared. And now this is something we can integrate. Now we're going to let u equal x squared. So letting u equal x squared, then du dx is 2x, so du then to be 2x dx. I have 2x dx here. So let's make the u substitution now. So let me write down here. So making the u substitution, we'll have then u of 0 to u of 1 integral e to the u du. Now u of 1, putting 1 here, u will be 1 squared, so it'll just be 1, and u of 0, putting 0, will be 0. And the integral of e to the u is just e to the u, so therefore this is 1, this is 0. So writing the next step. So again, integrating e to the u is just e to the u, then evaluating at 1 and evaluating at 0. So doing that, we get e to the 1 minus e to the 0, but e to the 0 is 1. So our final answer then will just be e minus 1. Okay, so there's our answer. So that's kind of neat, because we started with up here an integral we could not integrate initially because you had to do x first. So you can see by switching the order of integration around, it became something we could integrate. So, all right, so let's leave it there.